Ms. Toff. This is my reading log entry numero uno. I'm discussing a book called Out There. It is basically a big research paper talking about aliens, antimatter, and human space travel. So he basically touches on aliens, the power of antimatter, and like the flipping of the neutron to the proton, and then how humans are attempting to travel through space. So quite interesting. Perfect. Okay. So he starts the book with a little like monologue or story about the scientist who was looking through data collected by a telescope or radio transmitter. I can't remember which, but it was a big radio tower pointing into space, and it picked up this interesting signal for 72 seconds, which was interesting because it had a really interesting frequency and it had interesting spacing in between the wave, like interesting troughs and highs, which was deemed only possible coming from a long distance away. And he was stunned by this, so he wrote "wow" on the paper, and it's now deemed the wow frequency. And the scientific community was super intrigued by this, and so for the past 2 decades, they've been trying to find it again. They've been trying to prove that it wasn't an anomaly, because you can't prove anything if it only happened one time in the scientific community. So they've been trying to prove that it's not a fluke or a fraud. Unfortunately, there hasn't been another recreation of the signal, and no one's picked it up. But it was an interesting way to start. After that, the author, Michael Wall, who he basically starts talking about the size of space to try to build perspective for the rest of the book. So he talks about how large the universe is in comparison to what we think it is. And by default, the universe being that large means that there's an X amount of stars, an infinite amount of stars, that the universe is infinitely expanding, and there are universes with billions of stars that are farther than the eye can see, or that we can see with our telescopes and technology. So there's an infinite amount of stars, and it's been determined or hypothesized that there are more planets than stars in the galaxy, which means there are more than an infinite amount of planets by default. This is shocking because it obviously means that there are trillions upon an infinite amount of planets that exist. But it's kind of hard to quantify that as a human. So he started talking about the Milky Way galaxy. The Milky Way galaxy has it has about 10 billion stars in it. And it's hypothesized that 20% of those stars have planets rotating around them, which are in the green zone or the good zone, which means they're not too close that they would burn up, but not too far that they're like frigid ice blocks. So they sit right in that perfect zone that Earth currently sits in. And I think Mars technically is in the green zone, but it gets pretty far out. It gets pretty cold there. So he talked about how that happens, and I'm sorry, I'm really bad at talking to a camera. It feels weird not talking to a person. So he talks about the possibility for alien life to exist if just in our universe there are so many planets that could support what we know as life, and how there are creatures on the Earth that are incredibly adept to living in the most hostile conditions where they don't need oxygen, and they can survive temperatures up to 160 degrees Celsius and as low as negative 300 degrees Celsius. So the possibility for alien life is so high, it's almost like you can't really deny the fact that somewhere out there in the massive span of the universe there's life. And then he talks about an equation that I found quite interesting. It has a lot of variables because you can't define a lot of it, but it basically outlines the chance of an alien life form contacting us. And there's a lot of variables you have to talk about. You have to talk about where the life form is, how far it takes to get here, the type of communication they use, the language they use, how evolved they are. So there's a bunch of variables in the equation. That's why so many different numbers have been derived for the percent chance of this happening. But it was super compelling as to like, there certainly is alien life in the universe, but the chance of them contacting us is quite small. It's like less than a 0.0001%, because while humans think we know a lot, we really don't in terms of communication and like the forms that other life, like the other beings would take. And so he made a compelling argument for why they haven't contacted us yet, and it was super interesting. And that's as far as I've gotten. Let me pull up what I need to do real quick. Okay. So I felt it was shocking to me, because I've always like, I'm a firm believer, and I've been for so long, that alien life form exists. It's so impossible to deny that somewhere in the universe there are other forms of life. Just like with the quantity of planets, there's got to be other forms of life. What forms they take, and like how, like if they're like bacteria or they're like 750 feet tall, it doesn't matter. It still exists. And so I was kind of aware of this, but I think the way he worded it, as in like billions of stars and 20% of those have planets similar to Earth, was just shocking to me. I was like it's really interesting to think about, first of all, scale, and second of all, the plausibility of it being real. There's a lot of uses for this in my paper. Obviously, when talking about interstellar travel, there's always the conversation of an alien encounter, or like coming across alien life form, or coming into communication with alien life form. And so there's a lot of obviously steps we have to take to get to the point where we can contact alien life forms, but there's always the possibility. In addition, if aliens were to come to Earth, that means they would have had to travel using technology that allows them to travel interstellar. It allows them to travel trillions of miles, hundreds of light years, just to get to us, which is also compelling, because it's interesting to think about, we're not the only species that is developing technology, and we're not the only life form that is conceiving interstellar space travel. Within the galaxy, there are certainly people who are conceiving this, or not people, I guess, like aliens or ETs, extraterrestrials as they're referred to in the book, are conceiving this. So I think there's a lot of stuff I can use in the thesis paper. I think the book will apply more when we start talking about antimatter and space travel. But it is always interesting to address the point of aliens, because it's always a topic that comes up when discussing interstellar space travel. Hello, Ms. Toff. This is vlog number 2, reading out there. This chapter I just read discusses 3 primary reasons for why aliens haven't made contact, or we haven't made contact with aliens. The first reason discussed was humans don't care. And I'm sure humans care, and I think a lot of people care about talking to aliens until they have to like write the check for all the facilities and the technology and the people it takes to run facilities. Because, I mean, the operation costs of just a basic satellite or radio telescope are in the millions of dollars a year, and hundreds of millions for construction. So I think people care, but people don't care enough to like spend the money to find it. I think they're more prominent issues in the world. And then that's kind of what I received from the author. So that was interesting. The second perspective, or the second reason for why aliens have made contact, is they've evolved past radio. So right now, the only real way we're looking for humans is with radio, like detecting radio waves that travel around the universe, because it's the only way we have. But if you think about it now, who uses the radio anymore? Like, who adjusts the antennas on their television? People are now using cellular devices, and there's no really need. So the technology that we're using is outdated. And then he kind of went on to elaborate about how aliens could be using communication far more advanced than we have conceived or designed yet. So there could be, like, they're not even looking for radio signals anymore, because the radio signals are irrelevant in their society. So that is the second option. The third is, and what I feel the most compelling, is that we're the anomaly. were the civilization, or were the one planet that managed to survive. And I find this quite unlikely, as the author did, because first of all, the quantity of planets, which I discussed in my last vlog, but also in the perspective of the time the universe has existed, life on Earth has only existed between 3.8 and 4.1 billion years. And that sounds like an incredibly long, it's an unfathomable amount of time, but the universe is so much older than that you would think that other civilizations would have the time to develop. He also went on to talk about how the Earth is uniquely positioned. So we have a moon which stabilizes the rotation, so we get consistent seasonal changes, and Jupiter, who has a massive gravitational field that helps attract asteroids and comets to keep them away from hitting the Earth. And so the Earth is quite unique, but again, it's hard to imagine that in the billions of galaxies that exist that all contain billions of stars, there's not another planet that's similar. The odds of that are just too low. I thought this was super interesting. It's never really something I considered before. I've always considered that, like, the aliens are there, maybe they'll come, but I've never considered reasons for why we haven't contacted them. Another interesting point to add is we've only been looking for about 100 years for aliens using radio signals, and maybe less than that, probably 80. And again, in the span of the Earth, that's such a short amount of time, and then in the span of the universe, it's even shorter. So it's hard to imagine that we would find them. I think a really interesting analogy that he used to put it on perspective is, imagine you're looking for fish in the ocean. So you go to the ocean, take a water cup, scoop a cup of water out of the ocean, and there's not a fish in there. Well, then from that you assume that there's no fish in the entire ocean. That's equivalent to what we have done. We've explored such a small fraction of the existing space that we know that it's impossible to draw conclusions based on the tiny fraction that we have sampled, that we've tested, or that we've observed. And so I thought that was an interesting comparison, and it made a lot of sense in terms of putting everything into perspective, like a cup of water in the whole ocean. You can't assume anything off of that. This has a lot of use in my thesis for a lot of different reasons. First of all, again, the perspective of size is continually emphasized, and it's made quite important that we are super small. In addition, it talks about the how societies and how specific animals develop over the course of time. And it makes a compelling argument that we've really only had flight technology for 120 years. And so maybe interstellar travel isn't for the distant future if we make it that long. I think you can talk about that. I think you can also talk about communication in space and how radio waves and what we're currently using are quite insufficient. And we might need to devise a new way to communicate with Earth or with wherever we're staging the mission, in order to be more productive and not have to wait, because at distances of light years, radio waves travel slower than light, so it would take billions of years to get a signal, which is quite interesting. So I think there's a lot of applications of these three main reasons why aliens haven't talked to us to my thesis. Reading log numero tres. Officially made it to the second chapter. The first chapter is a pretty long one. I finished the second chapter. It's about the Mars first theory. The theory presents itself that Mars at one point was a much more habitable environment than Earth, on the basis that for a long time Earth was just an ocean. And that creates problems because water molecules are really good at breaking down molecules that are essential to life, such as DNA and RNA. Many hypothesize that RNA came first, and Mars was much more suited at the time to breed life, to habit life, because Mars was half ocean, half land, with very fertile soil. At the same time, Earth had just undergone a collision with another smaller planet called Taurus and was a magma field. And this is around 4.8 billion years ago. So life wasn't too habitable on Earth, but it was much more suited on Mars. And so the idea behind the Mars first theory is Mars was the original spot for life, the breeding ground for life, in the form of tiny bacteria, like not alien life, obviously not animals, not creatures, but tiny bacteria. That brings to the question, well, how did this life get to Earth? Mars jettisons a lot of debris, and a lot of it hits Earth. There have been multiple documentations of cases where Mars rocks have been found as meteorites crashing into the Earth. And I'm sure there's many more in the oceans and jungles, as Michael Wall outlined, which means that it's very conceivable as possible for bacteria to have started its growth on Mars and then was transported to Earth. Mars then would become a desert, but at the time, which was about 3.4 billion years ago, when we first see signs of life, it was a time where we can trace the Earth's gravity using light and like the gravitational field around Earth, and there was a ton of debris coming from Mars to Earth at that exact time, which is the basis of the claim that life was founded on Mars. Before coming to Earth, when Earth was a more suitable environment, it wasn't a magma field and it wasn't a complete ocean. There had been tectonic movement that created landmass in which these meteorites would land on and subsequently breed bacteria. I think this argument is compelling because it kind of contradicts everything we've known. Obviously, this occurred so long ago that it doesn't contradict evolution, or it doesn't contradict like the dinosaurs or the humans or aliens or mammals came from another planet, but it contradicts the theory that Earth is the only habitable planet for life. And I find that super compelling because for the longest time, humans have believed that Earth is the anomaly, whether you believe it from a religious standpoint or just from like a logistical, logical standpoint. It's always stood true that Earth is where life is and nowhere else is there life. But if the life that's on Earth originated on our stellar neighbor, which is currently inhabitable, I think it's quite interesting. I think it creates an interesting case. I think this can be used in my thesis a little bit less than the first two, but it still has meaning. In this theory proves that other planets are capable of life, like habiting life, like breeding life forms and supporting life forms. I mean, at the time, Wall describes as Mars was much more suitable to Earth at that time because it had a balanced supply of land and water at about 50-50, and the water was all fresh water. And there were rivers and there were lakes and there was structure. And so it supports the theory that Earth isn't the only planet, which is something a lot of people have a hard time getting over. Regardless if there's life on the planet or not, it's a planet that humans could exist on. Could, because they can't anymore. But it proves that it's possible. It proves that there is a chance that other planets right now can inhabit life, which builds the case for interstellar travel because it kind of doesn't create a necessity because it's not necessary for us to leave yet, but the chance of it happening is high, and this theory helps prove that it's possible.